So welcome everyone. We're going to be talking a little bit about what we're doing on Logic Apps to enhance the developer experience. We know that's a huge part of what we need to do as integrators is everything before it actually goes to production, right? We've been working especially on the local development code, trying to get that as close as what you needed to run that in many different scenarios that we have today. And for the agenda today, we have 3 items. We're going to talk a little bit about Workspace. So first, setting the scene of everything that we're doing, we needed to start look into that concept of Workspace a little bit more, right? Then we're going to be talking about how we can increase the code quality on local development with unit tests. If some of you were here last year, we talked about the unit test we did preparing for a private preview a year ago, right? Full circle. Let's see where we are with that today after a lot of feedback from you all and a lot of work from the engineering team. Then what types of custom components we can have, or like custom code and all the scripting technology we have to extend Logic Apps. And finally, these things that was like the biggest buzz yesterday, the Codeful workflows, right? So the idea is like having Logic Apps for all developers with no cliffs. And today we know that it's getting to a point where people have to move from another technology because of one of the reasons is not being able to work with code. So let's start talking a little bit about creating and organizing Logic Apps, right? I think since last year, like Workspace is nothing new on VS Code, but since last year, the year before, Logic Apps started to use heavily Workspaces. And why is that? First is a single place to look at multiple types of resources. And as soon as we started to do things that is more than just the Logic Apps project, for example, the custom code, that was the first one that introduced that, now you need a place to manage all those things together, right? The other thing is we needed some kind of prescribed structure when we're starting to help generating code for you. We have things like not just the custom code, but the unit testing, the generation of deployment scripts. All of that shouldn't be just go and be inserted inside the Logic Apps project. Otherwise, it would be a nightmare for you to be able to deploy that, right? So having that prescribed structure help us to identify the code from the extension point of view and be able to generate and regenerate as needed, but also generates that separation of concerns. So what we did with Workspace since, right? We know that it needs to be a little bit more of a first-class citizen inside that. So now we allow you to create workspaces from the beginning. So like what I really ask you guys is when you're creating new Logic Apps project, started with the workspace, right? Because from there, you'll be able to take advantage of all the other things that will bring it in pipeline to help you to manage that code, generate scripts, test, and all of that. Then the other thing is that we also include some of the gestures in the context menu. So if you needed to create a new workflow, before you have to go to Azure, you tab, click there, come back, right? That on a big project start to get like really taking toll. So we included some of those key gestures in the context menu. Right click, you have create a new project, create new workspace or new workflow. And when you go to custom code, for example, that means that you would be able to insert a custom code project or insert a new function inside a code, right? So creating that thing that you used to when you're working with other IDEs. Then what happens if I already have a Logic Apps project? And now I open with this new paradigm, right? So we're trying to help you to migrate to that in a couple of ways. The first one is if you're working locally and you open that project, you're going to see that kind of warning. If you click on no, it's fine. You continue to use the project, but you're not going to start taking advantage of those other things that you created. If you click in yes, then it goes through a process with you to not move, because I know that potentially that project at that point might be hooked up to other stuff, to your CI/CD, to other things, right? We copy that to another place, and then you have the control on how you're going to onboard that new workspace on the rest of your process. But from that point on, locally, you're going to take advantage of all the things that you have. The other thing that we're doing is the idea of cloud projects, right? So when you're talking about the cloud projects, it's like I develop in the portal. I did a really quick POC. I create it there. How can I actually bring that in a way that Logic Apps extension understands, and making all those changes that we know that are required from portal to local? That's why we created this idea of this cloud to local, taking advantage of something that is already there. There is the download the package from the portal, but then we create a process for you to create a new Logic Apps workspace from that package to speed up that process. And that's where we have like a very quick demo here just to show this cloud to local feature. And it's a really good test to see if the audio is working. Did it start? Come on, audio.
To export Logic Apps standard from Portal to VS Code, use the Download App Content feature to extract a zipped package. This downloads the workflow and all configuration needed to create a new local workspace. In VS Code, select the new option, Create New Logic Apps Workspace from Package. Select the package downloaded and follow the wizard to create a new Logic Apps standard workspace.
So, once you do that, you have a new workspace ready, right?
Remember to check the README file for any post-deployment activities.
We give like the things that we're not able to do ourselves. We give like a note on how to do it. Talking about notes, in about 2 minutes, we're going to have a fire alarm. Did I forgot to talk about that? So around 8:45, we're going to have a fire alarm test. Don't worry, don't leave. That's actually going to give me time to make sure that my machine for the next demo is hooked up. Okay, but let's continue. So next thing on our list is automated test framework, right? First thing that we wanted to talk here is actually what is unit test framework from the context of integration of workflows in general, but more specifically to Logic Apps, right? The idea is not testing a very small piece of code like you would be doing, like the smallest piece of code that you can test in code, right? For here, the smallest thing that it makes sense to test would be a workflow scenario. And what I mean that for a workflow scenario, like if you look at that example there, right? When I receive a message, I do some processing, then I have a decision tree, and then after that I do something based on that. My workflow scenario is what happens if I send data that it goes to the true path on that one, or what happens when I send data to goes to do the false path, or what happens when I send data and that data breaks my process, right? So 3 good scenarios to test here. But in order for you to do that, you needed to control the execution, right? It's not like send data, hope that that calculate discount code that we have there, or Logic Apps that we have there, does what you wanted, because you wanted to test the logic on this. It's not integration end-to-end test, it's the testing for that Logic App, right? And the way that you do that control execution is decoupling the testing from the external systems by allowing you to actually create mocks, right? So the idea here is that you would go and create mocks for everything that's either have inputs coming into the Logic App or going out to do stuff, which is usually our connector actions. Leave everything else that is actually the logic of the workflow for you to go and execute as it was running on the Logic Apps production runtime, right? So we inject mocks on that to get as much fidelity as you can. And then, based on that, you should be able to verify the logic, looking at the flow execution that is the same, like think about run history, a version of that you would be able to assert against what you expected that the logic apps would be doing. So you can look at the flow execution, so if certain actions executed as expected, but you also can look into correct outputs that you expected if you have like manipulation inside that.
Attention, please. Attention, please. The fire alarm is about to be tested. The fire alarm is about to be tested.
My machine
Please
is still
contact
here.
building administration if you have any.
It was not me. It was not me, okay? So let's see. I'll continue talking about that. If it's do like beep, 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 we stop it again. So, there we go.
Attention, please. Attention, please. We are investigating an alarm condition. It may be necessary to evacuate the building. Attention, please. Attention, please. We are investigating an alarm condition. It may be necessary to evacuate the building.
And I think it finished, or maybe not. Come on, mate, say that it's finished. Oh, let's continue because it's going to say that finished, right? When you're creating those unit tests, like we... Really?
Attention, please. Attention, please. The fire alarm test is now complete. Please respond to all future fire alarms.
There we go. We survived our fire alarm, and my machine is running. So that's good. So when you're working with the unit tests, we provided like 2 ways for you to create those unit tests, right? The first one is creating from an existing run. So think about the scenarios, and I think it's like that going to resonate with all of you. When you're doing the development, you actually need to do some kind of debugging, right? So you get the things, depending on the types of if you have the luxury to have access to those systems, to actually put data there and take data out, so you actually run that in debugging for a little sometimes. But the way to verify if it works is, I get that, I get a run, I open the run history, I look at all the results, eyeball everything. Yeah, it worked. Then I may miss that. I do that for my 5 or 6 different types of scenarios, right? Having said that, that run history is a really good place to start a unit test because you already had, after it is executed, you already have the data that you wanted. So you don't have to generate mock data. So first thing that we did is like to speed up the process of creating the unit test is you can get any of those runs that now all the data is there. Click on create from run is going to generate for you a unit test with the mock data in one place and the code on another one, so you can go and do your sessions or actually externalize or add to that, right? We really give like really basic boilerplate there. But we know there are other places where creating that, maybe you don't have access to the end system as a user to actually go there and put data, or if you add in data, then you have to go there and delete the data to then run that again, right? Because the end system might not be as idempotent as you wanted. So for that, we also give you the ability to create unit tests directly from the definition. And then in this case, you have a burden to actually generate the mock data yourself, but you have a lot more control on how you're going to create in that. When you're creating the solution, you have, like, we actually created a C# project using MS Test, right? And injected in the workspace that we just talked as using the C# dev kit extension. So we're not reinventing the wheel, we're using the tools that are there. Some of those things, what is going to give us to us is the ability to actually having all the IntelliSense that would come with all of that, and also hook up on the Text Explorer that I'm going to be showing later on. So same thing that we're doing for a C# unit test, you'll be able to do here for that. The structure is basically what it's talking. It's like one per workspace with one, if you have multiple logic apps in the workspace, one project per logic app, one area or one folder per the workflow, right? Because there are some components that are common there. And then the places where you're going to have your logic apps or your tests. Mock output classes is something that I'm going to show on the, it's better to see on the test. But basically, all those connection actions, if you have to go and create data yourself, you needed to give you a representation for that. So we created actually a class for each one of those mocks, right? Which means that you can go and create those mocks in code with all the IntelliSense and things, as much as it gives. Like some of those actions actually has a J object input or output, literally just a J object. So you have to go and create your J object. But if you have the structure like service bus or Dataverse, for example, that has like a really set structure, you're going to have access to all of that. Test settings connect you to your data, to your logic apps. And then the workflows, you are able to create mocks, as you said, if you create from run, or the C# class. So let's take a look at this in action. Because where we are on time, actually, let's see. My machine is still here. There it is. Let me open one other project. Sorry, wrong machine. That's the machine that I want to do. And okay, so what I'm going to show you first here is that create. I'm just going to do create from run, right? Actually, do create from run because give you the idea of that mock generation and stuff like that. But you can do the same process with the create from designer. And then we go to something where I already make some changes, like how we would be structuring the logic app out of that boilerplate to see that. Okay, so I have that running. And I go here to my process workflow. That is that one that I showed before. And I already run this, right? So I have a execution that succeeded. So in here you see, like I already have it executed with the calculate discount, all the things. I can simply click on create unit test from run. I give it a name. Super creative, right? As I always am. And yes, I trust. What it does, it creates a project with all of that structure that defined. And inside that, it put a list of all the mock outputs that we had. Oh, come on. Right, in this case, I had I have my trigger, my complete message, my HTTP call, my child workflow, and my abandon, right? All of that created, and here is just an example of the trigger. So I have access to my content data, to my content type. That is like all those fields that you have access inside the logic apps when you run. Okay. And on top of that, it created the project with the test, the mock. And this mock is a JSON file that has the data at that point, right? So let's go to my other project now. And on this one, I actually got the, I am on the other project or not? There we go. No, mouse, cooperate, please. So on that one, I created a set of tests here. And I'm going to show you some examples and some of these things that we can do. So let's take that test process order, for example, right? So I actually created a get mock definition, and then because I have multiple types of scenarios, I actually injecting the scenarios on my mock setup when I set up the data. So I do that, and then I can call that multiple times, just passing parameters, right? So in that data here, what I'm doing is I loaded the mock, but after that, I can go to my content data, for example, and change the region or change the status. So I can do load, take advantage of the run, but then update that for each one of the scenarios. And in my case here, I also calculate discount. I wanted that to be dynamically generated. So I actually create a dynamic callback, right? So this dynamic callback is going to be a code that we run when the test execution is running, and injects that at that point, taking in consideration the inputs of that workflow. So it's the closest that you get of the actually things being executed, but you're in control, right? So this code, as an example, is it gets the region name from the inputs. Depending on the region, it knows that this is my rules for discounted values, right? Then it goes and calculates, based as always $100, because it's easy for you to verify, what is the before discount, the discount, and then after discount. So it runs that all the time. And we have some other tests here as well. So let's go and run all of those tests and see what happens. So you see that it's like this is just like what we'll be doing with C# on code. It's going to be start building that, running all different types, and every time that is running that is actually calling that logic apps in the executor. I'm going to show that in a minute, and come back. Oh, I have lots of passes and one fail. What did I do wrong? I needed to do a demo. So what has got wrong in here, right? It gives you the information about that, if I'm able to open this. So what it's saying here is that the discount value should be 0.1, but I actually received 0.15. So that means it's probably something fishy on my logic apps. And yeah, it is fishy because I did that on purpose. So I'll go back to the logic app, and I probably did a what's the name? A copy and paste mistake. So just double check if that one is the calculate discount, which it is. So I'm going to open designer on that one. And then yes, my EU discount is 0.15. That's correct. My pack discount was supposed to be 0.10. It's actually 0.15. So super typical kind of error, right? You like you copy and paste to get it wrong. I'll fix my logic app now. I can save, and I don't have to run and then eyeball. I can just come back and run everything again. And if I get everything right, it's going to get that last one for last, but yes, it worked. So this is, go ahead, please. I let you do that, that's fine. So that's the kind of things that you'll be able to do with the unit tests, right? Let's go back to the presentation. We just go super quick on some of those things that we have on the SDK, and then we can get into the other items. So When you're looking at the test SDK, you're going to have some areas where you needed to have access to data to control your execution, right? And that is like your trigger mocks and your action mocks. So those classes that you have there, that when you load in from the JSON, it's just creating representations of those classes anyway, right, inside of the mocking object, allow you to do this. And here we have some examples where, for example, I creating a new list rows from Dataverse, and that one actually calling a dynamic callback, because I probably needed to do like loops, and then like creating all of that here would be super complex. But I also might need data from the input executions to do that. And my send service bus send message, where I create a message, and that's the funny one, because since the only thing that I needed for service bus in this case is making sure that it worked or not, I'm not actually sending the data, right? I just mocking that the data was sent successfully for the service bus. So in this one, I can just say, yes, succeeded. I don't need to create an output, because there is no output for me to come back apart from yay or nay. But in some others, like the Dataverse, I need the output back. So the mock output, as you're saying, when you needed to go and write, it creates that mock output class with the body, and you have like full access to IntelliSense. So try to imagine trying to remember all of those things from Dataverse, for example, to again having to go and write those things. Plus, the other advantage here is the only thing that I carry about in my Logic app is account number and name. So I don't need to give like the whole Dataverse stuff, since I'm only mocking for that Logic app. Then finally, the dynamic callbacks, as I showed you before. In this case, you see that I getting the account ID from my input, like I receive an account ID as an input. So to make sure that my data looks correct, because maybe I need that downstream, I get in the input account, I put in the account ID there, and just give like a fake value for balance. But I create an object for that HTTP execution that comes back and runs. When you run in that, like the things that you needed to do for a run is basically using that test executor. And this test executor, I think, is kind of the secret sauce here. What we do with that is actually loading the Logic Apps definition, the app settings, the parameters, everything that Logic Apps needs to tick, right? And instantiated a test host instance that is pretty much our runtime, but with flags to say, if you have this particular output, inject that, like similar to what it would be doing with statics result in a real execution, but a lot more dynamic, right? So you'll be able to inject all of that, still guaranteeing that you run in that as you would be running a Logic Apps in production, because it's exactly the same runtime with the bundle and everything else. Then you just do the test run, and you run this run workflow async, right? Receive a test run back. And the test run is what you use it to do stuff. Because the test run, in this case, is where you have that run history that we talked before. With that, you'll be able to do all types of assertions. You can look at if the overall workflow status of the thing was succeeded or not. You can look if its specific actions succeeded or not. You can look if the status of a particular one was succeeded or skipped. Like in my case, I just wanted to guarantee that it actually went through the true path, but then for extra assurance, that actually didn't run again that variable for some reason, right? And you can even do comparisons between parameters and other things. Like one case when we started to run this is, that's fine that I get my variable value against something that is specific, but most of the cases I doing that variable is actually pointing to a parameter, because then when I deploy to other environments, those values are going to change. And you can replace that session here. My value get the right parameter value at that point in time. That means that if I test that with another set, it is still valid instead of hard coding values. Okay? that's, with that, we now are in a place where we can consider an automated test framework in GA, right? You're going to be getting this on the next version of the extension, right? That is being in deployment this week. So by the end of the week, you should have access to pretty much everything that I showed. You already have that in public preview, but we did some improvements. If you wanted to know the improvements, we just put a blog post out with that, with some of the other things that we did, and making that announcement. So shifting gears, let's start talking a little bit about code here, right? So when you're talking about the code, the first thing, like the smallest thing that you can do in a Logic Apps with code today is injecting some inline script. Before, we only have support for inline script for JavaScript, but we also adding support for C# and having support for PowerShell, right? We are working towards getting those two in GA as well, so that you can ping me offline to find the dates, but we're expecting that more to the end of this month to have those items in GA. What is the audience for that inline script? Is you need to understand a capability of just that workflow, right? Like it's just workflow. It's on the context of the workflow. So you just needed to extend the capability of the workflow. You don't need it to external dependencies for that to work. You don't need maybe an extra DLL, or like your code is not overly complex. Or you have like you already have that kind of scenario, making sure that the other two are correct, but the language of choice is better done in either PowerShell or C# or JavaScript, right? Potentially Python, that is something that we have on our backlog to think how to get that as well. The next step in Logic Apps when you're going to be working with code is custom code, right? Custom code is not new for us. Like if I'm not wrong, with GA that integrated last year, and added the support for .NET 8 that was in public preview. We did a lot of improvements both on the process itself, but also on .NET 8, and I'm going to have a demo on that one soon. So when you're thinking about the custom code, some of the improvements that we did is with the feedback that we got a lot from people is, yes, I wanted to use custom code, but you're forcing me to create a whole new workspace just to get to the point where I can create a custom code, and then I have to go and copy my Logic Apps, right? Taking into consideration that we already show you how to convert the Logic Apps to a workspace, you don't need to do that extra step anymore. The next natural thing would be, can I just add a function project to my workspace, please? And now we say, yes, sir, or yes, ma'am. The next thing is some gestures, right? So in that case here, now we have like new function directly. It's like similar to what we discussed before, new project or new Logic app. You can also add new function on that context. But you also can do right-click build in here. So again, you don't have to go to terminal, .NET build, .NET restore. We provide that, so just to speed the velocity that you can get to the code in the right place. And we did the unified debugging. Before, you have to do start Logic Apps debug, start function debug, put those two together, then you run. Now you have an unified debugging, either clicking on this run debug Logic Apps with local functions, or F5. And both of them start up. From the .NET 8, which was like the one that we've been focusing since the .NET 4.7 was like there and stable, we did a couple of new things on that one. We did bring your own packages. We allowed for you to include packages, but we had trouble with that in relation of if you push in a package that you work for the host also required, the host won on that, right? So Rohita is going to know that a lot more than me, But my understanding on this is now we're running that on its own, the context of that custom code, isolated from the actual host in a way. And then because of that, you can bring your own packages. There is like only 3 packages that we reserve the right for us. There is logging, dependency injection, and the workflow extensions, right? But in theory, you shouldn't be able to need those ones because you're going to be working with that feature in itself. The other thing that we do is allow you to bring dependency injection for the custom code. So you can create your package outside, or you can use an external package and just inject that in the code using the industry standards. And we have a little bit of a process on how to do, which, if I'm not wrong, is the next demo. So let's go now to this guy. So what I have here is not a failure in communication. No one got that joke. Come on, people doesn't know Guns N' Roses anymore. So in this project, I have a Fort Coffee services project, right? So I'm just going to open that solution so you can see. And here I have a couple of interfaces. I have my discount services interface, my routing service interface, and and my implementation of that discount service that looks a lot similar to that. So think about this as the evolution of the last one. I don't need to go and create all of that as cases anymore because I actually can bring that logic that shouldn't be inside the orchestration outside on my custom code extensibility, right? So I have my discount service here. And just to show that it's not able to do just one, I also have a routing service because this guy here, Fort Coffee, is have places in North America, Europe, and APAC. And depending on the system, we're going to be sending that to service bus to a different place, right? So we have 2 services here. Those services, those places could change later. Again, decoupling the logic. And the way that I actually working with that, with my order router project in custom code, is I'm doing a couple of things. The first one is I'm setting up my services, my singleton services, using that startup configuration. So this is one of the things that you needed to do when you run creating the unit test, because this is how the host is going to identify those that you're going to inject that and look for services to inject, right? And then on your code, on your logic apps, when you starting the class, you inject instances of that, right? Then after that, you should be able to use, right, here I have 2 functions. I have order router and I have calculate discount. And each one of those uses the logic to get the data from the services, and after that, extend that with whatever logic you need. On this case, for example, I just get the calculation discount from the service, right? Because that can change seasonally or something like that. And then here I do the actual logic, the calculation logic. If I get this like in the workflow, is relatively easy. On this one, I just literally just showing, just getting those 2. Another good thing about that one is you don't have to build that to get the latest version of of those contracts here. We're actually doing a build before you open design first time, so you can get this the latest version. Like the problem that some people had with .NET 8, when I close my workspace, when I come back, if I open the Logic Apps first, I lose the context of the contracts, right? So on that one, I have my get discount and my calculate discount. And if I just run that, look, just one F5, and fingers crossed. So it started to build the project. It's going to build instantiate the Logic Apps and hook up both of them on the debugger. So when I run this, I can actually stop on the debugger for each one of those steps. Build succeeded. Logic Apps is about to start. Come on, Logic Apps. There we go, we have Logic Apps. And if I run that, I'm going to stop on the project, so I can do like a one-place debug with one-click debug for all of that, and just go for the first one. Then I can scroll down on the get discount, see how it's working. Yeah, looks like it's working fine. Complete. Have the response with the order plus my discount there, right? So this is one of the things that we did with custom code for .NET 8. That's the demo working. So let's go back here. Next announcement before we talk about the custom code. So custom code is also getting GA right now. Most of those items you actually can already find in the VSIX, the latest VSIX, right? And we just including documentation for you to understand how to do the startup configuration. But I gave like a really brief explanation on how you can achieve that on that blog post as well, right? While we're updating Learn. Finally, custom code workflows. So what is custom code workflows from our point of view, right? It's a new way to alter workflows in Logic Apps Standard. It's not a different Logic Apps Standard SKU or a different type of workflow. It's a new way to alter that. It's still a Logic Apps workflow. It's based on .NET and the Durable Task Framework, and it's using C# as the programming language. One of the things that it makes it special is access to our connector ecosystem directly in code, right? Which allows us to create those triggers that will not be able to do easily in another language, like if you're trying to use function, but also have a way to inside the orchestrations, to remove the need for plumbing, for all of those other things. And it coexists with declarative workflows in the same app. So that means that you don't need to make a choice at the beginning of your project. Do I need to use declarative? Do I need to use Codeful? You can mix and match because, again, behind the scenes, they are a workflow, right? It's a different way to write. It's a different way to execute, but inside the same runtime. So let's see if that demo that you tried desperately to see yesterday is going to run now.
Codeful workflows are a new addition to Logic Apps Standard that allows you to create workflows using imperative programming model, implementing your workflows using .NET and the Durable Tasks Framework. With this feature, you can combine workflows implemented in .NET alongside the existing declarative workflow model, enabling both approaches to be used within the same application. In this model, triggers are represented as client functions that listen to requests and starts orchestration functions using the Durable Framework. Customers are able to take advantage of Logic Apps' full fleet of triggers, which includes Azure services and the most common SaaS applications. The workflow logic, on the other hand, is represented as orchestration functions, blending code structures with Logic Apps connectors to implement your business process. Built-in actions are now converted to native code structures, simplifying the ability to set up complex logic and to reuse common code practices. Connector actions, on the other hand, are defined in a Logic Apps Connectors SDK, exposing both managed and service provider connectors with a rich authoring experience, with strong type models and a simple execution model, which encapsulates a durable task. Codeful and codeless workflows are part of the same application, running under the same Logic Apps standard application. This allows you to combine those workflows together, as in this example, where the Generate Coffee Recommendations Codeful workflow generates upselling recommendations based on an existing order, pushing the results to a service bus queue. The process coffee recommendation visual workflow picks up where the previous workflow finished, generating an email response and sending it to the customer. The same application can be deployed to Azure, where Codeful and Codeless work side by side as a Logic App standard, taking advantage of the same operational capabilities available in Azure from overview of the workflow execution to showing individual execution details for operational support.
Okay, so this time it worked. It's what you guys expected? Looks cool? Okay, that's what I wanted to hear. So why are we thinking about the Codeful workflows? First is like enable all development teams with no cliffs, right? If you want to work declarative, you can work with Logic Apps. If you wanted to work on code in some cases, but you needed to write the whole orchestration or the whole workflow in code, we give that. You wanted to go and do just code, you can do that. So you don't have now a place where I need to make a conscious decision to move from Logic Apps to other technology just because my requirements is better served in code, right? It gives you like better control over the some of the complex scenarios. Like we all have Logic Apps where they mushroom so big that's where the point to say, man, this looks is easier to write a function for because I can do on Logic Apps, but it's just really hard to maintain, right? You can still take what happened at that point is you made the conscious decision to trade maintainability for connectivity. And that's not something that we wanted you to have to do, right? So with Codeful workflows, you can still have that maintainability that you wanted because your workflow is too complex, while still taking advantage of the connector ecosystem. The other thing that is like a lot of customers pointed out is I wanted to create some of my snippets or my code practices or my development practices in a way that is reusable, right? I wanted to have my package of the things that I wanted to reuse. That is really hard to be done with the declarative way, right? You can create snippets, but then you have to get inserted on that and go back to that complex complexity that we had before. So you can do that. And one thing that a lot of people also raised in that is like that more granularity around logging. I love what the Logic Apps give me out of the box, but how can I add my own instrumentation? We have like limited things that we can do on the declarative one, but on code is anything that you can instrument is there, right? And you decided where you're going to be sending that. So if you look at a little bit about the components that I just showed, triggers are going, triggers and actions and connectors in general is going to be provided to you on a connections SDK, right? So, and the way that you're organizing that is like you have your service providers and you manage it. We discuss internally thinking about if you have a service provider and a managed, should I only give one of them? It's like, for us, it's still like you decide. We don't want it to make decisions for you, so we decided to get the SDK. Here is everything that you get. We're definitely going to give you best practice that we think that is going to be the best, but you decide which other components you're going to use. So we're going to be supporting both managed and service provider triggers, right? And one thing that you can notice here on those example is that they're going to have kind of a common signature. So your service providers are going to be like a new service provider trigger of type service bus. And then because of that, all the inputs that are required for that trigger and the strongly type output for that. For your email is a new managed trigger, so the managed connector trigger, but again, of type email with my Office 365 connection. And then inputs and outputs that are required. The important thing here is that those inputs and outputs is strong typed, so you don't have to like think about what is that I have to provide. It's not like an open box with a JSON that you have to try to find out what is the values. Everything that is defined is a strong type, so you know how to define each one of those. And most important, you know what is coming out of that output, right? So you can for you to actually pass to the orchestrations and then deal with that. Actions on on the other side that works in a similar way, right? We're still going to support managed and service provider connectors. It's going to be a strong type of classes, and you don't have to explicitly create an activity for that, because similar to the functions, each one of those types, the managed and service provider, they are behind the scenes a generic service provider activity or managed activity of that type. So we abstract that part for you, but it still works as an activity function, right? Finally, when you get into the cloud, right, we'll be able to run, as I said before, Codeful and declarative workflows together. So you don't have to segregate that unless you want to, but it's all under control. It's going to be running on any compute that Logic Apps standard supports. That means WS standard, ACE, and hybrid, right? And have the same operational capabilities. And I think that is quite important to understand, because one of the questions that a lot of you have since yesterday, right, at least at this stage, is will I have the full declarative view of my Codeful workflows? At least at this stage, the answer is no, right? Because that declarative view that you see on run history is a byproduct of you being forced to define the things declarative, including all your steps that should be just code behind the scenes. Your variable declarations, your condition controls, your for eaches. You potentially don't want to see that, but you wanted to see the result of things that happen there and only the things that matter for you. So we're going to provide the same capabilities. And when I say capabilities is, I can go to a specific workflow, right, in that one. I can see all the runs. I can zoom in on a specific one. I can see the values that you logged. And then potentially, because you have control on the logging, more than you would be seen on declarative, right? We're still working on that one. And, you should be able to resubmit and do the things that, operationally, the things that makes Logic Apps stick so well. We are planning to get private preview by the end of this week, beginning of next week, max, right? I think it's like the bottleneck right now is me, because I'm here on the conference, so I cannot send emails to people. But if you're interested on that, you can go to the blog. You're going to have a time to review that video and dissect, stop, get all the Easter eggs. There is no Easter eggs there, but if you find one, you can send it to me. And register this for the expression of interest. As soon as we have the data in place, we can send it to you. 1 minute, and we already have the question from Rick. Do we have a mic? Nice, arrived.
Sorry, hopefully a quick one, Wagner. Use of the word Codeful implies state. Are we going to be able to do stateless workflows with the Codeful approach?
No, sorry. When I say that Codeful, there is we're creating a durable function, right? So a durable orchestration. You decided inside the orchestration how you're going to be doing the state. But one of the things that you have in stateful versus stateless, the reason why we did that was to speed up. It was for performance reasons and for storage, right? All of that goes out of the way here. So I don't think we had that needed to have that distinction between stateful and stateless in this case, because you decide what you're going to log, and the logs and the only logs that is going that we're going to enforce, that you probably would want it in stateless anyway, is from the actions.
That's really interesting, because obviously our customers often gravitate towards functions for that sort of low latency scenario. So I think that's going to be really useful. I like that.
Cool. I think we're literally on time, so that I can get some of the other questions outside. And I was planning for 5 minutes, but then it was the 5 minutes that we sing and dance around the alarm. But hopefully that was worth the hype. And looking forward for you to test this and also unit testing and provide us feedback.